first 45 minutes of class, we have looked at concepts and terms from Gen Chem 1 and tried to think about the connections we can make between them. We've made these concept maps. We've just gone around and looked at other people's concept maps. Are there any thoughts that stood out to you? Is there anything that you saw over and over again that you either disagreed with or thought was very insightful? Can I hear some comments or thoughts related to the gallery walk and looking at other people's concept maps? Please share. Did you get a chance to look at your concept map with the comments on it?
No.
Okay, how about go do that. Spend 1 minute, look at the comments on your concept map. See what you think. And then I want to hear some comments when we come back.
Want to form a bond. Oh, no.
Yeah, I like the shape determined by molecule. And what about molecules determined?
Okay, when you've read all your comments, please go ahead and grab a seat.
Shape is determined by made of man.
So like let's say you have a whole
Oh yeah.
I'll just tell you as a professor, these are the kinds of conversations that I like to be dragging on and have people kind of like distracted by, is looking at things other people have said or taking ideas from other students' posters and trying to figure out how we can incorporate that. I've heard some really good conversations around that. Can I hear some comments either on what you had written on yours or what you saw in other people's that you wanted to either commend or correct?
One comment that we had on ours was when question mark on when we put protons equal electrons. We even think to put like in a neutral.
Yeah, I think that was a pretty common miss for a lot of people. They equated atomic number to the number of electrons, or they said protons and electrons are equal. And that is true when? If you're neutral. If it's not neutral, then you don't have the same number. So a lot of the definitions were just rusty, and they had to figure out, like, what is it that makes something helium versus hydrogen? It's not the number of electrons, it's the number of protons. So some of these things you might want to go back and just refresh through Gen Chem 1 textbook. A lot of, I think one of the two groups here, I can't remember which, said that there was another term that you wanted to add to yours that you saw on numerous other ones. What was that?
Like the moles and the Avogadro's number.
Yep.
For like stoichiometry and
So it's really hard to connect a lot of those terms unless you start talking about moles and Avogadro's number and some of the stoichiometry things. And I think electronegativity was at this group that said that you saw that in a number of places, and that was a useful one to connect. Other comments?
One of ours just says vague. So, you know.
Yeah, it's really insightful. So this is actually one of my favorite study tools, is if you can sit down, well, honestly, day to day, if you go through class and you're like, ooh, this is a big concept. So for today's class, we're going to be talking about electronegativity, we're going to be talking about polarity, we're going to be talking about dipole, some of these terms. If you just keep a list of these running, and then every week or every few weeks, you sit down with a group of your peers and try to figure out how they all connect together, you're going to be so much stronger during an exam because you're going to understand how things fit together, and you're not just going to have a whole bunch of terms. So this is one tool that I give you, and I hope that you can make use of. If you come to office hours and you're like, here, I have this list, like, let's work through it. That would be amazing. I would be super happy. Or you can have a set of problems. And I said in one of my announcements, office hours are in a way a lot like this, except it's driven by your questions. So don't think you come to my office hours and you wait in line to ask one question and then I ask you to leave. My office hours are 3 hours a week, an hour and a half on, what did I set up, Tuesday and Friday. If you decide to come to those, and usually it's groups of people. We say what types of problems you want to work on, what concepts you want to work with, and we work through those together in a group setting. I lead you to a point where you feel stronger when you leave than when you arrived. But I don't just sit there and give you answers. So if you have a problem that you've worked out, you want to just corroborate it, fine. I'll let you know that you're on the right track, you've done it right. But most of the time it's working together in problems. If you have a really personal issue you want to discuss, that might not be the ideal setting. Sometimes I can set people up to work on something and we can step aside and we can talk about something that, there's a car accident in the family and you need some time to whatever that is. We can talk about that. It might also be better just to set up an appointment. And if you can't make the office hours that I announced yesterday, on Blackboard, you can always email me, set up an appointment. You can always come. I try to get here half an hour before class. I try to stay after class, so those are always times that I'm available. If you have lab right after, I know that doesn't work out too well. But I try to be available as much as I can, so keep those in mind. On the concepts, there's one other big one that I saw a lot of challenge around, and that was energetics. If you have breaking a bond and energy, how do you put those two together in a sentence? I have one hand raised volunteer. Amber?
And you break a bond, energy is released.
Does everybody agree?
Yes.
I see heads nodding and heads shaking. You were shaking your head, why?
Because
bond breaking requires
because they want to be together, be like satisfied. So.
Make it sound like a relationship.
Yes.
Well, I mean, it kind of is. It's a bond. So.
It is a relationship.
Yeah. So I
So
think
it requires energy to keep them apart.
one of the biggest misconceptions in chemistry that is the hardest to break is that breaking bonds releases energy. If that happened, then you would never have the atoms together in the first place. So atoms form bonds because they get an octet. They become more stable. So if you're undoing that stability that was formed, you have to put energy in. It doesn't work otherwise. So that's one of the things that just walking around the room, you can see that. I love this tool because you can see that misconception play out, and then you can address it fairly easily. The part of this concept map that we're going to be using the most today and through the next couple of weeks, polarity, covalent bonds, ionic bonds, all these kinds of things. So with that said, let's go ahead and I'm going to do a couple slides here, and then we're going to get into activity 23. So for every class, if you recall, I mentioned this earlier, every class I'm going to tell you what I expect you to be able to do by the end of class. And if I forget to do this, yell at me. So for today's class, I expect that by the time you leave, you will be able to pinpoint areas, at least some, in your Gen Chem 1 knowledge that you might need to refresh or go back and study, or you maybe never learn in the first place. I want you to be able to identify polar bonds. That's the activity we're about to get into. And I want you to be able to predict whether a molecule will have a measurable dipole moment. If these words are gibberish to you, but you think there's some concepts or some terms in there that you might want to put in the concept map later, you might want to write those down. We will also, I mentioned this in an announcement as well. This class has so much content and concepts in it that there is no way I can get you to the finish line of the American Chemical Society final exam that you have to take as part of the department just with the time we have in class. So I do require you to work outside of class. That's why we have the homework, that's why we have the primers and all those kinds of things. In addition to that, we've been able to secure a little bit of funding and some very generous individuals to help work with us in class. These two, Josh and Diana, and you met Tripti last class. But they've also been able to figure out a way to run out-of-class workshops. They are not required. So if you are unclear on how the grading of them works, please check out the email that I sent. But basically, to summarize, 20% of your course grade comes from homework, and or workshop. If you go to no workshop, none at all, 20% of your grade comes from your homework, and that's it. If you go to every single workshop, then 16% of your grade comes from homework, and 4% comes from workshop. And you basically get 100% for every workshop you go to and work through the material in a productive manner. That kind of boxes out people that can't go to the 2 time slots that we selected. So we basically said that we're going to give you the material here. That's the fracking activity that you see, one of the activities you see in front of you. So if you still want to try to earn 100% on the the workshop activities, you can do that and bring it to me by Wednesday's class, or you can drop it off maybe a day or 2 later if your schedule doesn't allow right away.
The workshop activity, do we have to log in on it? Do we have some exercise, something like
So that's the activity, is the fracking activity that you have in your hands. So we handed it out. So if you are going to come to to our workshop tomorrow night, 6 to 7, or Wednesday, 4:30 to 5:30, those are both in this room. If you're coming to one of those 2 times to work with either Josh or Tripty during those times, they will guide you through the activity. Only come to one, and don't do the activity before you come. The point is they're going to help guide you through the activity. It's going to be a structured time where we work together as a training group. And so Josh or Tripty are very capable of helping you lead through the activity in a way that you'll come out stronger than you did when you came in. If you can't go to one of those 2, you can still complete the activity and turn it in, and we'll look for if you went through and completed it in a way that looks like you tried to work through it, then you'll get the same credit as if you were here. Jesse?
So we're going to be doing the same activity both days?
Yes, there are not 2 separate activities. Right.
So just come to one.
Come to one if you can. If you can't, you can either decide I'm not going to do it. If you want to do it and still get some of the workshop credit, you can do it and turn it in to me in class, or you can decide not to do it. It's a way to try to encourage you with some points to do something that, if you're able to, will help your understanding of the course. Okay? So that fracking activity, you can go ahead and put that away. We're not going to be working on that tonight. The other activity is POGIL Activity 22, Chem Activity 22. That is also a review activity. We will be using the front page of that today, but we're not going to be doing that activity in class. So if you're not comfortable with polar bonds, you might want to go back through that activity as well. I printed it out so you'd have more material to practice on. Yes, Jessica? Okay, they're up here. Josh can give one of those to you. Anyone else who wants them, you can come grab them up here. All right, and the last kind of announcement thing here. Has anyone ever thought about being a teacher? Interested in being a teacher? So at UA Little Rock, we have a National Science Foundation grant that encourages science majors to think about teaching. It's called the NOIS program, NOIS Scholarship. It used to be $10,000 a year scholarship for your last 2 years as an undergrad. Now it's $15,000 a year for your last 2 years as an undergraduate. They're trying to spend the money. They're trying to recruit teachers. You have to commit to 3 years of service in an underprivileged part of the state of Arkansas afterwards, but that's pretty much anywhere in Arkansas. Sorry, that wasn't meant to be judgmental. You have a lot of options of where you go. That's what I was trying to say. So if you're interested at all, Google NOICE and UA Little Rock. And there's actually, teacher salaries are higher than you'd expect. There's better benefits than you'd expect. There's time off. There's a lot of reasons why, if you're interested in science, that being a doctor or a PA or something like that is not the only way to go. It's my little plug for being a teacher. Teachers are awesome. Okay. I think that's all the announcements. All right. Chem Activity 23. Go ahead. Please read. Hardest thing to do for students is to read carefully and thoroughly before going on to the questions. Don't go to the questions. Go ahead and start reading Chem Activity 23. Go ahead and read through the front page, and then the second page, and then we'll get to some questions. once you've gotten to the questions, you can start discussing them in your group.
How did they determine
You're trying to figure it out.
Because you have like, the way this is set up, they're going,
Well, I mean, it's just kind of the average. Both of these, you think about it, it's a lot.
I've been very bad at that.
Well, it's like a right triangle. So when you get pulled that way and that way, that is just like the hypotenuse.
This is hard to write down, like a word. So individually, oxygen is more negative, so like it's saying here, the dipoles are going that way, but overall, when you look at the molecule, it's going this way, where it's positive on one side and
Well, they're
negative
both
on the
on,
other.
both on one side, so.
And then that's how they get it like that. Thank you.
This is a little bit confusing because of that. Pretty much this is probably going to be much less confusing for you, but pretty much, so it's all about electron activity. So it's always going to move from positive to negative. Because it cancel out, the net sum of the vector is going to be this direction. So, if you really wanted to get super in depth, I would make
Well, is that something that we're I need to do?
Right where.
very basic.
It were like that.
Rise of some photons out because of the direction.
There's like
We
molecular
actually,
shape.
this
So, like if it were linear, it would cancel out, but since it's bent, the positives are on one side and the negatives on the other side.
Because it's got those, it's got little pairs over here.
Yeah.
Two positive charges are in the hydrogen.
Yeah, so this is like, those are the hydrogen and oxygen, and it's like overall, they're still pointing in one direction. So you get a positive end and a negative end.
And if it were straight, that would not be the case.
So it's saying like when you look at this is the more positive and this is the more negative. So
Well, it's just trying to find where. Yeah.
It's gonna be highway. They can't say
Yeah. Because it's kind of like the two charts and the distance.
Think about it.
It's like either the
is it midway because they're the same?
And so, they say counteract it. Since you have positive from two different directions, show it in the. Yeah.
Like the very next question. Like looking at the valve.
So if CO2 if CO2 was bent like water, what
yeah, I mean, it's still like, well, it's all related to waves. Or, yeah, I don't know how this are positive charge and partial positive. Like, I don't know what makes it like, but there are polar bonds, but the CO2 molecule itself is not polar.
So
That's what I was trying to say. That's why it's zero.
So let's talk through, if you don't get question 1 nailed, then the rest of it's going to be kind of tough. So how do we figure out where the center of that partial positive is? What are the steps that they did in order to get there? You guys know my number?
They started out by mapping out the, which element was more electronegative, and since there's 2 bonds in it, you have to map out each one separately.
Fantastic. Did everyone do that? So when we're talking about the polarity of a molecule, we can't go anywhere until we look at every individual bond. 2 atoms make a covalent bond. That covalent bond may or may not be polar. It depends on the electronegativity of the 2 atoms in it. So we're going to look at each of the bonds. So is O to H a polar bond? How do we know that it is?
Because oxygen is more electronegative than hydrogen.
Great. So what this arrow is pointing at is that there's a bond, covalent bond. How many electrons are in that bond?
2.
There's 2 electrons in that bond. Those 2 electrons, we're showing them as equally shared. There's a line, right? It's connecting the 2. But that's kind of a lie. What we know is that electronegativity takes those 2 electrons and moves them closer to one that has a slightly higher or stronger electronegativity. If the electronegativity difference is so big that it's actually pulled all the way to one side, we call that an ionic bond. So the extreme of a polar bond is ionic. In this case, it's not an ionic bond, but we're going to say that there's a little bit of a negative on the oxygen, a little bit of a positive, because those electrons are being pulled more towards the oxygen. They're going to be found there more of the time because electrons are negative. That means it's a little bit negative. If you were to tell me that that is a negatively charged oxygen and it's an ionic compound, I'm going to be upset. I'm going to go back and I'm going to talk to your Gen Chem 1 teacher and I'm going to give them a very hard time. Okay, and then we can say the same thing for the other side. So each one of those is showing a polar bond where there is a slightly positive hydrogen, a slightly negative oxygen on both of those. And so you can do that in two ways. You can either show the dipoles, the partial positive and partial negative, or you can draw a dipole. And it says on the first page, I think that arrow, the tail with a plus end to it, that is where the partial positive charge is in that one bond. And then the arrow points towards the partially negative one. So a lot of times they teach us how to determine polarity in a molecule by adding vectors. You have to know molecular shape and a whole bunch of other things, which is great, and hopefully we're going to get to that. Not today. But the other way, the other approach to figuring out if the molecule is polar or not is saying, where is the center of any of the partial negatives? Where is the center of any of the partial positives? So where is the center of the partial positives in this case? So I'm going to put a plus. I'm not saying it's a positive charge. That's where the center, that's the point in between the two partially charged hydrogens. Where is the center of the partial negative charges? It's right there. Are they on top of each other? Are they in the exact same physical location in 3D space? They're not. So if they're not directly on top of each other, that means that you have a polar molecule. That's kind of how this approach uses it. Is it says, think about the three-dimensional space. Think about where the center of the positive, center of the negative are. If they are in the exact same spot, it's non-polar. There is no polarity. So the next question asked about CO2. Is that right?
Yes.
CO2 is, what is the exact wording of it? Why is the dipole moment 0 for CO2? Meaning it doesn't have a net dipole.
Sorry, I missed the part. How is the center of the charge determined? Is it just adding the two vectors of the dipoles?
It's not about vectors. It's about if the center of the positive and the negative are on top of each other, then there is no dipole. If you have to draw a line connecting the center of the positive and the center of the negative, then there is a dipole. It's polar. And so the center of the positives is just physically in space between the two partial positives. Is that what you asked? So between, this is partial positive, that's partial positive, so where's the middle of those in space? It's at that point there. Does that answer your question?
I'm just confused at how that answers the question. Like, how would you put that in words? Like, I get what you're saying right here,
Yeah.
drawing out.
So the steps, I guess, would be determine if there are any partial charges in the molecule. And then based on the three-dimensional, where they are in 3D space, we then figure out where the center of those are. So with CO2, is that the same?
No.
So if we go all the way back and we say this is a Lewis structure, we're going to have our lone pairs. We need to think about where the dipole, where the partial positives and negatives are. So this involves a lot of different steps, which if you're not comfortable with making your Lewis structures and doing molecular shape, that's something to identify and go back and work on. So where's the center of the positive and where's the center of the negative in this one? Center of both of them is right here. So that means that it is non-polar, there's no dipole moment. Looks like we're out of time. Before you leave class, I want you to log into iClicker and make sure that it counts you as being here for today. And I'll do a question just for the sake of doing a question. Let's do... Let's do this question right. No, I don't have it. Okay. We're just going to do a multiple choice question. Answer however you want. If you're not sure how to log in,
Oh, you just have to click it.
yeah, just click any answer. It'll just count you as being here for the day. If you have not yet created an account and logged in, we can help you do that. What's that?
Click a button.
Click any button, any option you want. The only homework assignments coming up are there's a primer for Wednesday. You have homework for the end of the week. There's also two other things on Blackboard that you've probably seen. Most people have taken the syllabus quiz on Blackboard. and uploaded your plagiarism certificate. So those are 2 things on Blackboard.
Sorry, just to be clear one more time, this is if the center of the positive one and the negative are on other
Correct. So let's catch up in a second. Alright, so we are done with class for today. If you have any questions, feel free to see me. And I hope to see you all in office hours, either to help identify things you might want to work on them from Gen Chem 1, or to work on some of this new stuff from Gen Chem 2. We are in Chapter 11 of the book, which you'll see if you connect out from the front.